Soh-Cah-Toa, we should remember, this should be reviewed, that in right triangles, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So those words opposite and adjacent depend on your perspective. Hypotenuse is the same the whole time. So in a triangle like this, we have angle A, angle B. We're not going to worry about the right angle in a right triangle when it comes to Soh-Cah-Toa. We'll use the unit circle to evaluate trig functions at 90-degree angles. But for the acute angles, A and B. For sine of A, right, we'll do A's in red, and we'll do the B's in blue. So for angle A, this is our perspective. What angle is opposite, or what side is opposite angle A? Side A. The hypotenuse is side C. So sine of angle A is opposite over hypotenuse. The cosine of angle A is adjacent over hypotenuse. B over C, and the tangent is opposite over adjacent. A over B. And it's the same exact idea when we move over here to do angle B. It's just our perspective switches to being from angle B, where opposite is B, adjacent is A. Hypotenuse is obviously still C. So the sine of angle B is B over C, cosine is A over C, and tangent is B over A. So we went through that rather quickly, but that's because this page should be entirely reviewed. Should have seen this stuff before. Solve the triangle. When I tell you to solve a triangle, what that means is find every single piece of missing information. Every single one. In this triangle, we have been given 3 pieces of information. This is 90 degrees, this is 32 degrees, this is 8. This side length is 8. So there are 3 things we need to figure out. The easiest one to figure out first is the measure of angle A. To do that, you can use the idea from geometry last year that the 2 acute angles in a right triangle have to add up to be 90 degrees. You could also use the fact that all 3 add up to 180. You'll get the same result. So the measure of angle A is 58 degrees. So now we have 2 side lengths to figure out. Let's start by figuring out B. And one way to figure out what side B is we could say tangent of 32 degrees is B over 8. So we're going to need our calculator because we don't know an exact value for tangent 32. And in our calculator, you need to make sure you're in degree mode because that angle is measured in degrees. To solve this equation, then, you're going to multiply each side by 8. You're going to get 8 tangent of 32 degrees is, and let's round our answer to the nearest thousandth. What is that side length going to be? 4.999. That is side B. To finish solving the triangle, we need this, which we could use trig functions to figure out, or Pythagorean theorem. Oh, yeah. We know this is 8. We know this is 4.999. So side C, we could say C squared is 8 squared plus 4.999 squared. Solve that for C. What do we get?
You got that right.
9.433. So we now know every side length and every angle measure in the triangle. We have solved the triangle. Finito.
Cool.
What is a function inverse? If I have a function like this, f of x is 2x minus 7, just as a quick review of function inverses, we could rewrite this as y equals 2x minus 7. Right? F of x and y are interchangeable. What is the first step toward finding the inverse from here? We would say x, after I get the pen, there we go, x is 2y minus 7. Solve that for y. We get x plus 7 is 2y. So we get y is x plus 7 over 2. And the notation there is f looks like to the negative first power. That's f inverse of x. So that is how to find an inverse, which is not something we need to worry too much about today. It was just as a quick review of how to find an inverse. What's more important is, why are inverses important? F of f inverse of 2 is going to be the same thing as f inverse of f of 2, which is what? 2. The nature of an inverse function. If I plug a number into f, and I plug that result into the inverse, it's just going to undo whatever f did. So if I plug 2 into f, then plug that into f inverse, I just get what I started with, 2. Same thing here. If I plug into the inverse and then into the function, I'm just going to end up right where I started. That is what's important today. That becomes important when we're looking for missing angles in a triangle. So for example here, I could say in this triangle that the sine of angle A is A over C. From there, I could say that the inverse sine, because sine is a function, so I can take the inverse of that function on both sides. Like this. And using the property from the last page, the inverse sine of the sine of A is A. So we would get this. So the measure of angle A, we could say, is the inverse sine of A over C. We could also say it's the inverse cosine of B over C, or we could say it's the inverse tangent of A over B. Any of those three are going to give you the same exact answer. So when you are looking for a missing angle measure, that is when you use an inverse trig function. A lot of times people get confused. Should I be using the function? Should I be using sine, or should I be using inverse sine? The only time you use inverse sine or inverse cosine or inverse tangent is if you are looking for a missing angle measure. If you're looking for a side length, you don't use the inverse. Solve the triangle. Again, find all the missing information. We could start by finding side A. How do we do that? A squared plus 4 squared is 7 squared. So A is the square root of 49 minus 16. Rounded to the nearest thousandth, what is that? So this is 5.745. Now that we know that, we can say the measure of angle A could be the inverse sine of 5.745 over 7, or it could be the inverse cosine of 4 over 7, or it could be the inverse tangent of 5.745 over 4. You should get the same thing no matter which of those three you plug in. Now the thing is, there will be a slight difference between this answer and this one because we rounded this 5.745. But they should be really, really, really close to each other.
Yeah.
So this is approximately 55.150 degrees. And again, I checked and plugged this one in. If you plug this one in, you get 55.156, which is close enough. I would take that. That's fine. So how do you plug in inverse sine? Second sine. Inverse cosine, second cosine. Inverse tangent, second tangent. So now we have the relatively easy task of finding the measure of angle B. That's just going to be 90 minus this number, which is 34.85 degrees. What is the value of sine for the angle in standard position whose terminal side contains the point 3, -5? These are vocab words that we have gone over in the past, admittedly a little bit ago, so we may not be totally comfortable with it. Angle in standard form whose terminal side contains the point 3, -5. So let's say this point right here is 3, -5. Standard position means the initial side is here, terminal side contains this point, and the angle then we're talking about is this guy, which we can call theta. But we discussed in the past that if you could find a coterminal angle, that the value of the trig functions would be the same. For example, the sine of 0 degrees and the sine of 360 degrees are exactly the same because those two angles are coterminal. So our coterminal angle will look at this one, which we could call phi. Phi. And we could think about this triangle right here, which I could draw out. There. We have phi. We know this is 3. We know this is -5. We could do Pythagorean theorem to find c. What is c? This, using Pythagorean theorem, 5.831. Now that we have figured out the hypotenuse, we can say that the sine of phi is opposite over hypotenuse. Which is -0.857. But since phi is coterminal with theta, we could also say then that sine of theta is going to be the same thing, -0.857. And that's what they were asking for. What's the sine of theta? So we use the fact that coterminal angles will have the same trig values. This is another point of clarification. Phi and theta, since I use different variables, you can tell, they're not the same angle, but they are coterminal. Another part that tends to confuse people in a very understandable fashion. We do not know what theta is, and we do not know what phi is at this point. We could figure it out, but we weren't asked to. And as I've said in the past, if the minimum weren't good enough, it wouldn't be called the minimum. They asked for the sine of the angle. We found that. We do not know what theta is. We do not know what phi is, and that is perfectly acceptable in this case. So the idea of the angle measure thing there, I could say that the sine of angle A is 4/5, which is 0.8. So the sine of angle A is 0.8. I don't know what the measure of angle A is, though. Don't need to know the measure of angle A to figure out that the sine is 0.8. Angles of elevation and depression. You're on a sailboat at sea and spot a 786-foot bluff on the shore. You measure the angle from your sailboat to the top of the bluff and find that it is 16 degrees. About how far are you from the shore at the foot of the bluff? When you do angles of elevation and depression, you can safely assume that your picture will be a right triangle. So start with a right triangle, and then you just have to put in the measurements where they are supposed to be. So if I label this A, B, C, I know the measure of angle A to be what? 16 degrees. And I know that side A is 786 feet. And they are asking me for one specific measure. What are they asking me for?
Distance from sea.
They're asking, how far are you from the shore at the foot of the bluff? They're asking for B. So we don't need to solve this triangle. We just need to find one thing. And the way we can find that one thing, since we know what this angle is, 16 degrees, we can say tangent of 16 degrees is A 786 over b. How do I solve that equation? Got to start by multiplying by b, so I get b tangent of 16 is 786.
And you,
Then what do? Divide the whole thing by tangent of 16. So we get b is 786 over the tangent of 16, which rounded to the nearest thousandth
is 2,741.108.
0.108. And what are the units? Feet. It's not working. There we go. So that's how far we are from the foot of the bluff. In this one, the grade is 6%. So if I have this, A, B, C, this is side C, side A, side B. I know that A over B is 0.06. 6%. So then I know that the tangent of angle A is A over B. So then the measure of angle A is the inverse tangent of 0.06. Again, if you're looking for a missing angle measure, that is when you use inverse trig functions. So you get that the measure of angle A is 3.434 degrees. That's the measure of angle A. They say if you travel 3 miles along the highway, how much will your altitude have changed? Which side of the triangle is the highway?
C.
C. We know that C is 3, and in that case, if C is 3, what is A? That's what they're asking. So we know the sine of A is A over C. So the sine of 3.434 is what over 3? So A is 0.18 miles. So on that particular highway, if you drive 3 miles, your altitude will have changed 0.18 miles.